Hello, my dear viewers. I also welcome us to this episode of my discussion. Today, we are going to discuss more on calculus. We want to give a fundamental approach to calculus. First of all, we need to know what is calculus, but I think I will show more by examples. But in calculus, we need to know what is integration and also differentiation, because these are the two ways we can solve calculus. So calculus is a mathematical approach to some questions that borders on area, sum, and also slope. So first of all, having known about this, we need to know what is integration. Integration, that's this one I have highlighted now. Integration is just a fundamental concept in calculus. We can use it to find the accumulated area under a curve, or also to find the total sum of continuously varying quantities, that is, quantities that vary. You can also determine the area and the cumulative measure. In fact, it is the reverse operation of differentiation. We can also call integration antiderivative. So I write it now, antiderivative. So that is integration. Having gotten this clue now, we have to go to differentiation. What is differentiation? We can also call it derivative. So I can say in my own understanding that it represents the rate of change of a function with respect to its variable. Rate of change of a function with respect to its variable. That is, it can measure how a quantity changes as its input changes, given the slope of the tangent line. That is, if you want to know the rate of change of something, how the x is changing with respect to y, that is just the best way to understand it. So you can use it to understand the motion. Like you can say, like acceleration is the speed versus time. So you can use derivative to know the acceleration based on, you differentiate the speed with respect to time. So you can use to know motion and optimize some functions. The main thing is that it has to calculate the rate of change of things. It's mainly used in engineering and especially physics. It can also be used in economics. You want to know the rate of how money is increasing based on some conditions. There must be a condition to determine it. So now, to go further, we need to know some of the simple integrals and the derivatives. We need to know the simple ones. But now what we are going to concentrate more now is on indefinite integration and the differentiation. That is the one that has no limit. Just differentiate or integrate as it is. For instance, the cos function. Whenever you see cos, the integration is always sine. If you integrate cos, you get sine. So cos s is equals to sine x. Then if you differentiate cos, you get minus sine. Just this is how it is, which means that if you're integrating minus cos, you can still get minus sine. And if you're differentiating minus cos, you still get plus sine. So that's how it works. Then for sine, if you integrate sine, you get minus cos. The same thing if you differentiate sine, you get cos. Then again, we now have cos 2x. If you integrate cos 2x, integrating cos 2x, we now have sine 2x over 2. Then if you differentiate cos 2x, you now have minus 2 sine 2x. Just the only thing you have to know is that each time when we are integrating, the value is being divided. That is, we brought the value below. The variable 2 is the constant is 2. So we bring the constant below. And then for differentiation, you bring the constant before the variable. So that's how it goes. Variable are the ones that change, like sine can change to cos and so on. But the constants are the numbers. Then again, we have sine 2x. If you integrate sine 2x, you have minus cos 2x over 2. Same thing here. If you differentiate sine 2x, you now have 2 cos 2x. Just I want to give this so that it will help us with our future calculations. Now talk about ln x. If you integrate ln x function, what do you get? I will solve it later, but the answer is, I will just write the answer here. The answer is x ln x minus x plus c. Remember, all the integration will have plus c, while all the differentiation we have what do we call, we have dx. Even if I don't put it, but what is more important is to get the proper value. So plus c means plus some constant that we follow up. Then if you differentiate ln x, what do you get? When you differentiate ln x, you have 1 over x dx. Now I have 1 over x here. 1 over x simply means x raised to power minus 1. So I think I will come back to this so that let us understand, because I want to take it step by step gradually. Let me begin by doing x squared and x and so on. Now for x squared, if you the integral of x squared, the way to do it for integration is, you just need to, now that it is x squared, all you need to know is that add one more power to the already existing power and then divide by the value, by the total power you will now have at end. For instance, this is x squared. Now it's going to be x cubed, x raised to power 3 over 3. Very simple. Assuming it is we are given x raised to power 5, then it will be x raised to power 6 over 6. So it's very simple to do it that way. So now for the derivative, that is for differentiation, if you are asked to differentiate x squared, all you need to do is that power, the value of the power, write it as a constant before the x, and then subtract the power from 1. Subtract 1 from the power. Now we have x squared. So what you need to do first is to bring down the 2 that makes it x squared, and then subtract 1 from the power. Now become 2x raised to power 1, which is equals to 2x. You know, if it is power raised to power 1, I don't need to write raised to power 1. Assuming we are given something like x raised to power 5, what you're going to do is you bring down 5 here, then write x, then the power, reduce it by 1, and x raised to power 4. So it's also very simple. Now we have only x. So if you want to solve it in a way that it will be better for you, just write something like this. Just write something like this, x raised to power 1, so that you help you to solve it at the initial stage. So if you're asked to find the integral of x raised to power 1, what you need to do is x raised to power 1 plus 1 over 1 plus 1, which is equals to x raised to power 2 over 2. Very simple. So even if we are given x raised to power 5, or let me x raised to power 10, what do you need is to x raised to power 10 plus 1 over 10 plus 1. So x raised to power 10 is going to be x raised to power 11 all over 11. So that's how it's going to be. So for the derivative, what we're going to do now is it's going to be x. We are given x. So normally, assuming if we are given, let me say 6x, if you are given x raised to power 6, sorry. If you are given x raised to power 6, all you need to do is bring down this value here, and then next step is x. This is step 1. Then step 2 is equals to 6 minus 1. So the first one is bring this value here, the power value, make it a constant beside the x, and then reduce the power by 1. So these are the 2 steps. So now, having x now, what you need to do, just for you to get it now, right, that you have 1 x raised to power 1. So it's going to be equals to, you bring down this 1 here, it's now going to be 1. Then x raised to power 0 is equals to 1. So 1 times 1 is 1, which is equals to 1. So 1 dx, that's the answer. That's the answer. Because 1 minus 1 is equals to 0. 1 minus 1 is equals to 0. So 1 dx. Now we have another one, exponential function, e raised to power x. So e raised to power x is equals to e raised to power x. The same thing, e raised to power x is equals to e raised to power x. Now, e raised to power minus x. For integration, all you need to do is almost the same way. For e raised to power minus x, e raised to power minus x, all you need to do is you bring down this value here. And then divide by 1. So that is over 1. So because there is no, with 1x here, x, there is no other constant there, that is 1. So it's going to be equals to e raised to power minus e raised to power minus x. That's the answer. So the same thing here. Just for the integral, you bring down the minus equally, and then minus 1e raised to power minus x, which is equals to minus e raised to power minus x. That's the answer. Well, for this one is e raised to power 2x. What you need to do now is, for the integration, you need to bring the constant under. So you're going to be e raised to power 2x over 2, which is, you can write 1 over 2 e raised to power 2x. Then for the integration, it's going to be, you bring the 2 as a constant before the e. So 2 is going to be 2e raised to power 2x. So this is the final answers. So I now come to the one of ln x, the one of 1 over x. Normally, when we meet 1 over x, the integration is ln x. The integration is ln x. Now, but you can, for this one, for differentiation, what you need to do is consider 1 over x as x raised to power minus 1, and then use the power rule, that is the rule to do x squared and so on. What is the rule for differentiation? The rule for differentiation is you bring the value by the side and then subtract 1. So what you need to do is, there is no value. What you need to do is now is going to be x raised to power minus 2, because minus 1 plus minus 2, that is the answer, which is equals to minus 1 over x squared. That's the answer. So I encourage you now, to having had all this thing now, we can do some minor examples or some other examples following this. I think I have solved this one before in the previous video. So let's continue from here. Assuming we are given x minus 1 ln x dx. So when you see x minus 1, like I said, this very question, know that it is the same thing as 1 over x. Just know it. Just like 1 over x. Just like we did here. So we're going to continue with this one. X raised to power minus 1 ln x dx. So like I said, whenever you see ln x, make it your u. So our u here is equals to ln x. And then du, from the example I gave us, if you ask to differentiate ln x, what you have is 1 over x dx. And then if you are asked to find and then for dv becomes x minus 1 dx. And then what is the integral of x minus 1? That is equals to ln x. You see the reason why I gave us all this thing, like, look here. The integral of this is equals to this. So it will help us to understand this math very well. So having gotten the parts already, now we have to add it to the formula, and then uv, that is ln x, v is ln x multiplied by ln x minus the integral of, so sorry, before I continue now, let me just explain this one more. Normally in integration by parts, this is what we are doing now. We have entered integration by parts normally. So for the integration by parts, we need to first of all find our u, dv, du, and v. So and now that as we are given this very question now, we will choose to the one that we make our u. Like if I make ln x my u, that means x raised to the power 1 dx becomes my dv. So if you choose one, the other one becomes dv with the dx there. So now I choose ln x to be my u. Therefore, dv will become x minus 1 dx. And then du will become the integral, will become the antiderivative of u. That's the antiderivative of ln x, that is equals to 1 over x dx. And then v will be the integral of x raised to the power minus 1, which is equals to ln x. So now, I will now input all these values into the formula. And what is the formula? The formula is this one we are seeing now. That's this. The integral of x raised to the power minus 1 ln x dx, that is integral of u dv, is equals to uv minus the integral of u v du. So I'm going to input the values into this formula now. Let's go. So we now have uv ln x equals to ln x, then v is ln x, so the ln x minus ln x minus the integral of v is ln x, and then du is 1 over x dx. So this is the first part. We need to rearrange the equation. What you need to do now is rearrange the equation. We now have is equals to ln x squared minus the integral of ln x. Then this one is, you can call it 1 over s, you can call it x raised to the power minus 1 multiplied by x raised to the power minus 1 dx. So normally, when you meet the same value as the question given, for instance, this question, we have the integral of x minus 1 ln x dx is equals to ln x squared minus the integral of ln x raised to the power minus 1. I can reverse it so that it represents this very well. X raised to the power minus 1 ln x dx. As you can see, these two values are now the same. What you need to do is to combine them and then get the answer immediately. How to combine it? You shift the one that at the right side to the left. So shifting this one here, we now have 2 integral of x raised to the power 1 ln x dx is equals to ln x squared. So now to get the answer now, you have to add 1 over 2 to both sides. So that if you add 1 over 2 to this side, then this 2 will get cancelled. Or another point, another way is just simple to shift this 2 to this side so that it becomes over 2. So now it's now going to be the integral of x raised to the power minus 1 ln x dx is equals to ln x squared all over 2. That's the final answer. Now we have to solve this one again. We now have ln x squared. Remember what I told us about ln x? Our u become ln x squared. Then our du becomes 1 over x, because from the examples I gave, if you integrate ln x, if you differentiate ln x, you have 1 over x equals to 1 over x squared. And then the remaining part here is 1 dx, so that is going to be our dv, 1 dx. And then if you integrate 1, you have x. So our v is going to be x. So we're now going to add this into this part, the parts now. We have uv, that is ln x squared. Then v is x minus the integral of x. And then du is 1 over x, 1 over x. I want to make, because it is squared, so that it becomes clear, dx. So now, normally 1x will cancel. This x cancel. What I have now left is 1 over x dx. So we continue. It's going to be x ln x squared minus the integral of 1 over x dx. So 1 over x dx, if you integrate 1 over x, you get ln x. That's one thing you need to know. If you integrate 1 over x, you get ln x. So we now have x ln x squared minus the integral of 1 over x minus ln x. And that's the answer. So ln x squared is equals to x ln x squared minus ln x. Simple. That's the answer. Now this one, x cubed e raised to power minus x dx. What do you do here? Find u. U is going to be, can make x cubed u, and then v du is going to be 3x. Remember our way, du into 3x squared, because it's going to bring 3 in front and then reduce the power by 1. Then dv is going to be the remaining part, that is e raised to power minus x dx. And then v, our v is going to be the integral. If you integrate e raised to power minus x, what we are going to have is we're going to have the integral. It's going to be minus e raised to power minus x. Simple. So now we are going to input these values into the formula. uv is x raised to power 3 minus e raised to power minus x minus the integral of minus e raised to power minus x. Then du is 3. Sorry, I'm supposed to write dx here. Du is equals to 3x squared dx. So now have minus x cubed e raised to power minus x minus the integral of, and when you have 2 minus, it's going to be plus the integral of 3 x squared e raised to power minus x dx. Now at this point in time, we are going to differentiate. We are going to find the parts of this one too. So the same way, going to find u and so on. So I use green for the second part of the integration by parts. So u is going to be x squared, and the du is going to be 2x. Then dv is going to be e raised to power minus x. That is, it's going to be the same thing. And then v is going to be the same thing. So only the x value changed. So we're now going to continue, which is equals to minus x cubed e raised to power minus x plus 3, which will be distributed to u is x squared, and the v is minus e raised to power minus x minus the integral of minus e raised to power minus x. Then du is 2x dx. So now we continue, we rearrange the equation. We now have minus x cubed e raised to power minus x plus 3, because this one has minus, the sign will change, minus 3 x cubed e raised to power minus x e raised to power minus x. Then we distribute this 3 to this value already in bracket. So it's going to be minus minus here. It's going to be plus 3. 3 times 2 is going to 6. Now it's going to be plus 6. Integral of x e raised to power minus x dx. So it's going to be equals to minus x cubed e raised to power minus x minus 3s squared e raised to power minus x plus 6. If you integrate, we're going to do another form of integration. So here our u become x. Our u will now become x, and our du becomes 1 dx. Then the rest will be the same thing. So what we have now is u is x, v is the same thing. That is, so uv now going to be x into minus e raised to power minus x, and the integral of minus e raised to power minus x. 1 ds is going to be dx. So now we rearrange again, minus s cubed e raised to power minus x plus 3 x squared e raised to power minus x plus 6, which should be distributed to, sorry, where did I put plus here? It's going to make a mistake. Yeah, okay. Now this 6 now will be multiplying the values in the brackets. So if 6 multiplies x minus e, is going to be minus 6. Then so we now have minus 6 x e raised to power minus x. Then for this one is going to be plus 6 integral of e raised to power minus x dx, and then the e raised to power minus x dx is going to be minus e raised to power minus x. So I'm going to add it here immediately. So it's going to be minus 6 e raised to power minus x plus c. So now we have to rearrange. There is something that is common. E raised to power minus x is here, e raised to power minus x is here, e raised to power minus x is here, e raised to power minus x. So we'll bring it as a common factor, which is going to be equals to e raised to power minus x. And then we put others in bracket. And all of us have minus here. Minus, 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 minus. So we'll bring minus e raised to power minus x and now have x cubed plus 3x squared plus 6x plus 6 plus c. This is the final answer. So now we have another question. Determine x ln x dx. X ln x dx. The same way, I believe by now you must have been following well, and everything must have been becoming clearer to you. X ln x dx, normal, our u will be ln x, and then dv will become x dx, and then v will become the integral of x. If you integrate x, we have x squared over 2, and then our du will become ln x. If you differentiate ln x, we have 1 over x dx. So we now add this to the formula immediately. uv is ln x multiplied by x squared over 2 minus the integral of x squared over 2 multiplied by 1 over x dx. So normally at this point in time, 1x we cancel 1x. So we are now left with 1 over 2s cubed equals to 1 over 2 x cube ln x minus the integral of 1 over 2 x dx. Yes. So we now have 1 over 2 x squared ln x minus 1 over 4 x squared plus c. That's the answer. Because if you integrate, let me make it step by step. Sorry, let me make step by step. Minus 1 over 2. When you integrate this one, it now becomes x squared multiplied by x squared over 2 plus c. So it's going to be equals to 1 over 2 x squared ln x minus 1 over 4 x squared plus c. That's the answer. Now this is the final one we are going to do. The integral of x raised to the power 4 is going to take quite long, but we'll make it. So we now have our u. Anyone you can choose anyone and make it your dv or make it your u. So I use x cube s raised to the power 4. X raised to the power 4. I normally like to use red. X raised to the power 4, and then this is e raised to the power minus x dx. Sorry, that's going to be dv. dv is going to be e raised to the power minus x dx, and then du is going to be, if you differentiate, going to be 4x raised to the power 3, and then v is going to be minus e raised to the power minus x. Okay, and then go ahead. I think after doing this thing, I will reverse the ordering of the u. I will make this one that becomes u now become dv. So uv is x raised to the power 4 equals to x raised to the power 4 multiplied by v is minus e raised to the power minus x minus the integral of minus e raised to the power minus x du is equals to 4 raised to the power x cube dx. I change this into this, which is equals to, I have to rearrange the equation. We now have minus 4 minus x raised to the power 4 minus x raised to the power 4 e raised to the power minus x plus the integral of e raised to the power minus x. Sorry, I write for x first. Minus 4 plus 4 to the integral of x cube e raised to the power minus x dx. We are now going to find the parts of this one too. So it's going to be, this is going to be x cube, and then v is going to be correct. Du x cube to be correct. Then d is going to be 3x squared. Then dv is going to be the same thing. dv is going to be okay. So now the integral of, that is the integral of x raised to the power 4 e raised to the power minus x dx is equals to minus x raised to the power 4 e raised to the power minus x plus 4, that will be distributed to x cube is what? What is our u? Our u is x cube, so x cube, and our v is minus e raised to the power minus x, and the du is equals to 3x squared dx. So we now rearrange it again, which is equals to minus x raised to the power 4 e raised to the power minus x plus 4. This one is not going to be 4 again, it's going to be minus 4. Minus 4x cube e raised to power minus x. And then this one is going to be plus 4 integral of 4 times 3 is going to be 12. It's going to be 12, not 4. Plus 12 because of this 3 here. Because of this 3 here. So plus 12 with the integral of x squared e raised to power minus x dx. And at this time point again, we're going to perform another integration by parts. We're going to part this one. We're going to find the various parts to this very one. So what we have now is our x is now going to be, u is going to be x squared. This one is going to be the same. The next one is going to be 2x dx. And then this one is still going to be the same. So we continue, which is equals to minus x raised to power 4 e raised to power minus x minus 4x cube e raised to power minus x plus 12 that will be distributed to our u is x squared. V is equals to minus e raised to power minus x, and then minus integral of minus e raised to power minus x multiplied by our du is 2x dx. So we now have to rearrange it again. It's going to be equals to minus x raised to power 4 e raised to power minus x minus 4x cube e raised to power minus x plus 12. It's not going to be plus 12, it's going to be minus 12 because of this minus here. So we're going to have 12 minus 12 x squared e raised to power minus x. Then this one is going to be now this one is going to be, there is 2 here, so this 2 will multiply to, you now have 24 plus 24 into plus 24 that will be distributed into x e raised to power minus x dx. Sorry, I need to plus 24 e raised to power minus x. Sorry, with x should come first. 24x e raised to power minus x dx. So this time around, we still have another integration to do. We keep going like that. This one, I guess this is going to be the last one. So now, as usual, we're going to find our u. Our u is going to be equal to x, and our du is going to be 1 dx. Then while others will be okay, others will still be the same. So we continue, which is equals to minus 4x e raised to power minus x minus 4. Sorry, that's a mistake. Sorry. Minus x raised to power 4 e raised to power minus x minus 4x raised to power 3 e raised to power minus x minus 12x raised to power 2 e raised to power minus x plus 24. Now plus 24 4 that will be distributed into x, and then minus e raised to power minus x. Yes, it's going. Then let me adjust this more to save more space, because I might not have enough space at the end. Okay, now plus 24 that will be distributed into x minus e raised to the power minus x minus the integral of minus e raised to the power minus x dx, because dv is going to be dx, 1 dx. So you have to conclude minus x raised to the power 4 e raised to the power minus x minus 4x raised to the power 3 e raised to the power minus x minus 12x raised to the power 2 e raised to the power minus x plus 24. Well, it's going to be minus now because of this minus sign here, or this minus sign here, this minus sign here. It's going to be 24. So it's going to be minus 24x e raised to the power minus x. Then this 24, we now multiply this integral now. And if you integrate this, first of all, it's going to be plus, but if you integrate, it's going to be minus. So it will end up being minus 24 e raised to power minus x plus c. Now, what we need to do now is to find the things that e raised to power minus x is here, and it has minus. E raised to power s is here, and it has minus. E raised to power s is here, and it has minus. E raised to power x, e raised to power minus x is here, and it has minus. E raised to power minus x is here, and it has minus. E raised to power minus x is here, and it has minus too. So we now distribute it according to here. You now have minus e raised to power minus x, which should be now distributed into x raised to power 4 plus 4x raised to power 3 plus 12x raised to power 2 plus 12x squared plus 24x raised to power 1, then plus 24 plus c. That's the final answer. So this is the final answer.